Prove that sec square theta minus tan square theta is equal to 1. This can be proved in two methods. One by converting sec theta and tan theta into sin theta and cos theta form. And the other method is we can use Pythagoras theorem to prove this. Let's see one of the method, then we will see another method. Sec square theta minus tan square theta is equal to 1. We have to prove this. Now we will take the LHS part. Sec square theta minus tan square theta. Here sec square theta can be written as 1 by cos square theta, because 1 by cos square theta is sec square theta, and tan square theta can be written as sin square theta by cos square theta, as tan theta is equal to sin theta by cos theta. Then in next step we can take the LCM. Here LCM will be cos square theta. Then cos square theta by cos square theta is 1 into 1 1, and again here cos square theta by cos square theta is 1 into sin square theta is sin square theta, so 1 minus sin square theta by cos square theta. We know that 1 minus sin square theta is equal to cos square theta. This is because sin square theta plus cos square theta is equal to 1. So by transposition method we can find that cos square theta will be equal to 1 minus sin square theta. So in place of 1 minus sin square theta we will put cos square theta. So cos square theta by cos square theta, here it will be 1. RHS is 1, thus LHS is equal to RHS. So that sec square theta minus tan square theta is equal to 1, hence proved. Now let us see the alternative method to prove this sec square theta minus tan square theta. And we will use Pythagoras theorem. First let's take a triangle ABC which is right angled at B and angle CB theta. Here it is written, you can read, let triangle ABC be a right angled triangle right angled at angle B and angle CB theta. And here the figure which is shown. According to the Pythagorean theorem, we know that square of the perpendicular plus square of the base is equal to square of the hypotenuse. Here AB will be the perpendicular as it is facing to theta, and BC will be the base, and AC will be the hypotenuse as it is the longest side of the triangle as it is facing to the right angle of the triangle. Then AB square plus BC square is equal to AC square. Now we will divide BC square in both the sides. By dividing BC square in both the sides, then we will separate BC square in both the terms of numerator. As from here we can see that BC square will be the LCM, and here we will BC square, then it will come AB square plus BC square. Thus AB square by BC square whole added to BC square by BC square, then equal to AC square by BC square, as BC square was divided here. Now we know that A square by B square is equal to A by B whole square. Similarly we can write AB square by BC square can be written as AB by BC whole square. Now BC square by BC square will be 1, so here plus 1, and equal to, similarly AC square by BC square will be AC by BC whole square. AB by BC will be tan C. Here look in the figure, AB is the perpendicular, BC is the base, thus tan theta is AB by BC, as tan theta will be perpendicular upon base. So tan C will be AB by BC. So AB by BC can be written as tan C plus 1 is equal to AC by BC can be written as sec²C. This is because we know that sec theta is equal to hypotenuse upon base. Here AC is the hypotenuse and BC is the base. So sec²C is equal to AC by BC. So AC by BC is written as sec²C. Thus AC by BC whole square will be sec² whole square. Now tan theta whole square can be written as tan square theta. Similarly, here it is written that tan C whole square is written as tan²C plus 1 as it is. Similarly, sec² whole square is written as sec²C, which implies tan²C minus sec²C is equal to minus 1, because if we will transfer this here, then it will be minus sec²C, and we will transfer 1 to this side, then it will be minus 1. Thus tan²C minus sec²C is equal to minus 1. Here it is transferred from here from plus to minus, as sign will change as it will be transposed, then it is transposed, so the sign is changed. Now we will multiply minus 1 in both the sides. By multiplying minus 1 in both the sides, here it is minus 1 is multiplied. Minus 1, we know that minus 1 into tan²C will be minus tan²C, and minus 1 into minus sec²C will be sec²C. So minus 1 whole multiplied with whole of tan²C minus sec²C will be sec²C minus tan²C, and minus 1 into minus 1 will be plus 1. So sec²C minus tan²C is equal to 1, and this will imply sec² theta minus tan² theta is equal to 1, as we have assumed that angle C is equal to theta. So now we have proved that sec² theta minus tan² theta is equal to 1, but both the methods. Hence proved.